So on 43, one of the very first things that I think you guys would have the inclination to do is to turn everything to sines and cosines. Okay? You don't have to always do that, however. More important than turning things to sines and cosines when you're trying to solve, it's very, very important on these problems that you get 0 on one side. So to do that, I'm going to take away 1 and add 2 sine x. So I've got 2 sine x tan x minus tan x. I'm going to add 2 sine x, and I'm going to take away 1, and I'm going to get 0 on one side. Now I'm seeing 1, 2, 3, 4 terms. How do you factor something with 4 terms in it, typically? You typically factor by grouping, right? So if I'm going to group, what could I take out of the first 2 terms? I could take a tangent of x out, right? If I take a tangent of x out, I get 2 sine x minus 1. And here I have a 2 sine x minus 1 already, so I'm going to take a 1 out. And I have 2 sine x minus 1 in parentheses again. So factor by grouping, you have to factor something out of each of the 2 terms so that you get the same thing in the parentheses. And then when you have the same thing in the parentheses, now I only have 1, 2 terms. And what they have in common is a 2 sine x minus 1 and a 2 sine x minus 1. So I can factor that out, 2 sine x minus 1. And what I have left is tan x plus 1. Questions about the factor by grouping? I know that it's been a while since you've probably done factor by grouping. So you group the first 2, factor the thing in common out, and then you should get the same thing in both sets of parentheses, and you factor it out, and you write down what's left. Now, once you do that, you have to set both of these equations, or both of these expressions, sorry, equal to 0. So you're getting 2 separate things, 2 separate equations that equal 0. Now, a lot of you guys were identifying that tan x equals negative 1, and you solved that equation. When does tan x equal negative 1? Well, it equals negative 1 when the root 2 over 2's are opposite. So that happens in quadrant 2 and in quadrant 4, where you have 1 positive root 2 over 2 and 1 negative root 2 over 2, right? So that happens at, what, 3 pi over 4 and at 7 pi over 4? And then since they're only pi apart, you could probably just write 3 pi over 4 plus pi k, because that would add pi each time, and that would take it. Now, did they want the answers between 0 and 2 pi for this? Or did they want all answers? I can't remember, was it? So for number 43, let me just double check real quick. It says, find all solutions to the equation between 0 and 2 pi. So for this one, you would say x equals 3 pi over 4 and 7 pi over 4. However, you get 2 answers from this 2 sine x minus 1. So I would say 2 sine x equals 1 and sine x equals a half. And then I would have to think to myself, where on the unit circle is sine x a half? Well, I had to go up a half. If I go up a half, I'm here or here. So that's at pi over 6, or at, let's see, 1, 2, 3, 4, 5 pi over 6.
Oh no, it's sine.
Because its sign is going up, yeah. And so x would also equal pi over 6 or 5 pi over 6. Now, you guys weren't getting this because a lot of you were dividing at some point. You were canceling 2 sine x minus 1 out. Do you see that somewhere on your paper? Where you divided both sides by 2 sine x minus 1 and canceled it out? When you reduce in an equation, you're typically reducing out answers. You're removing answers, which is bad. And you could see that you were removing answers because if you graph this initial equation, there should be 4 intersection points. Okay, on your graphing calculator. You should see 4 times that those 2 equations cross. And so you would know that somehow you remove some solutions. Are there questions on this problem? So the big thing you have to take away is that in these problems you have to get 0 on one side and you have to factor.